Okay, part 2. This is the DNA chromosome, and we're in section -6. DNA chromosome right next to the smallest known free-living eukaryote. It's the smallest animal. It's called the osteococcus. The osteococcus with all of its nucleuses and its everything, organs and such. Whoa, what the fuck? Wasn't supposed to do that. Just a second. Gotta center it again. Okay. So, DNA chromosome. Osteococcus or whatever. Now here's all of the visible light. Ultraviolet, violet, blue, and these are the sizes. These are the sizes in, oh whoops. There we are. These are the sizes in microns. I mean, not microns. What's down below? Whatever. 455 of something units, which you have up there. Actually, you could say 0.455 of a micron. Green, yellow, orange, red, and this is what we see. So anything smaller than this, you can't get the picture of it. That's why we don't have a picture of the colors of the DNA chromosome, because it's smaller than the wavelength. We don't have pictures of the viruses. These are just guessings of the pictures of the viruses, because visible light is smaller than that. But that's how big the visible light is. Visible light sizes are very similar compared to each other. As you can see, the smallest is this big and the largest is this big. And the largest of the visible viruses, or the visible light crest-to-crest wavelengths, is about the size of the smallest infrared wavelength, which is a little bit smaller than red. It's about as big as red-orange. So let's go down one. This is 10 microns. This is the osteococcus, the smallest animal, DNA, herpes virus. Chromosome, DNA chromosome, herpes virus, pox virus, AIDS, flu, and such. Visible light here. And this is the red blood cell next to the smallest animal, or the red blood cell next to the DNA chromosome. So here's the chromosome inside of the nucleus of the red blood cell. So it's not that much smaller than the red blood cell, to tell you the truth. It's maybe as big as, I don't know what. I don't know. Not really that small. Kind of similar to the moon to the earth. So here's the bacteria, the smallest of bacterias. Or not the smallest. The smallest of bacterias are, I didn't put them here. About as big as that. So here's all of them, a real picture of them together. So bacteria on top of a red blood cell. Bacteria are small. Now look at these little alveoli. This is 2 microns right here. These little sensors are smell, human olfactory receptor neurons. That's what we smell with. Very small cells. So there's the smallest bacteria, and there's the largest of bacteria that actually have cilia. They have hair and tails that help them swim along and go to where they want to go. And there's the transistor gate, so the bacteria is even bigger than a transistor gate. But you can get a bacteria stuck on your olfactory cells, as you can see, but not swim around on. So let's go up one. Here's a human sperm. This is 100 microns. Oh shit, I forgot to time myself. Oh wait, oh no, the thing says it. That's good. Okay. So, 100 microns. So there's the smallest human brain cell. Now this is the smallest, it's called a terahertz. It's the smallest radio wavelength. Goes all the way across. Oh, whoops, gonna have to center this again. There. And this is the smallest human brain cell. Here's the smallest human, this is a human sperm. Here's a microelectromechanical device. There's 10 UMs, 10 microns. There's the fruit fly eye. Here's that bacteria. Here's a colloid sphere, colloidosome. Oops, sorry, but I don't know what that is. This is a dodecahedral quasi-crystal. And we have crystals that big stuck in our pineal gland, so don't put toxins in your body or they're going to get stuck to your pineal gland. Actually, here's a crystal that is actually stuck on a pineal gland. So you can clog out your pineal gland with crystals this big. And here's a clump of bacteria. And here's some more stuff that we humans can make. Nanomechanical resonator, silicon, nanopillar, microelectromechanical devices, the little things sticking up. The globulum of a mouse kidney. Capillary turf surrounded by Bowman's capsule, interferons of vertebrate kidney. So there's a kidney. Capillary. A mouse kidney. So here's a coagulation of red blood cells. Right. Oh, I don't have the red blood cell. Here's a coagulation of red blood cells. There's the red blood cell there, and that's what they look like together. They're kind of like flat pancake looking things. So there's blood. There's the size of your blood droplet right there. And this is a human hair. I'm assuming somebody with thin hair. And there's a nanowire on top of it. Nanowires can be very small, much smaller than a hair. Here's a pollen grain. And here's that oval bacteria. Remember that big bacteria, the largest of bacterias? You can actually see it compared to a human hair. And we can all see human hair. So we're getting to like the size of your actual eyesight. So maybe if your eyesight's really good, you can actually see an actual red blood cell, because that's what a red blood cell, you can spit, what, 10 of them across the human hair? That's pretty interesting. And there's a white blood cell, a little bit bigger than a red blood cell. There's a lichen. Micro hinge. Look at those hinges moving. They're very small. Okay. Let's go 10 times smaller. 1 millimeter. Now we all know what a millimeter is. Here's the largest of infrared wavelength right here. And here's a terahertz. It's the smallest. It's the largest radio wavelength. Potential replacement for X-rays in some medical applications. So the largest wavelength is this big. And there's the largest infrared wavelength. So the largest infrared wavelength is maybe a third of the size of the largest radio wavelength. Or maybe I meant smallest radio wavelength, we'll see. And as we recall, this largest infrared wavelength, actually that's the largest infrared wavelength. The smallest infrared wavelength is about as big as your eyesight wavelength. I should put the size of the smallest infrared wavelength here. Anyways, here's the largest brain cell. The smallest brain cell is this little guy. So 10 times smaller than that. The little tiny in here would be next to the largest brain cell. I should put it next to this. So the smallest brain cells are much smaller than the largest brain cells, but there's the largest brain cell, which you can actually see. It's 10 times bigger than this. The human hair would be maybe that big across. Anyways, look at this. If all the way across the screen is a millimeter, this is a micromechanical device with chains going around cogs. I don't know how they made them that small, and I don't know what they use them for, but that's pretty dang small. Microelectromechanical device. There's another one that's very small. So there's the smallest human brain cell compared to the largest human brain cell. I should put them together. Okay, there's the amoeba. There's a pulmonary alveoli. Those are the little sacs that absorb oxygen from the air. That's how big it is compared to a hair. It's maybe a third of the way across, half the way across a hair. Not all that small, but those little blood cells that absorb it are small. Might want to make you think twice about smoking. I don't know. There's a nanocoil, a nanocog. I don't know how they make things this small. Here's an electron micrograph of a flea head in the same size. Now here's all those other things that were in the other page above. So this is the size of a crystal that was taken off of a pineal gland. And if your pineal gland gets covered with crystal, you're not really going to be able to use it, are you? Not going to be able to connect your mind to your soul's eye. Smallest of bacteria, or largest of bacteria. Here's a sperm. Right here, a sperm next to a human hair. So a sperm, okay, it doesn't go all the way across human hair. It goes maybe a 20th across, 15th across of a human hair. There's the smallest fruit next to a salt grain. There's a sperm next to a salt grain. Human ovum next to a sperm. Yellow mite. So mites are extremely small, that big next to a salt grain. Dodecacanal quadrille crystal. You can see even on the smallest sizes, like if we saw on the crystal above, the crystals grow according to certain sizes. Here's the smallest fairy fly, which is the smallest insect. A little bit smaller than the mite. Here's as big as here's a needle tip with a coagulation of red blood cells above it. Here's a human hair next to a mite and a sperm. Oh, so the sperm. Oh yeah, so the sperm can kind of reach almost all the way across a human hair. I got that confused with the section above it. Wait, hold on. Yeah, that was the section above it. Make sure to remember the demarcation lines. Here, new demarcation line. This is a centimeter. The smallest microwave is this big here. And here's the largest, all the way across is the largest extremely high frequency, EHF, in radio astronomy, or high frequency micro radio wavelength. It goes all the way across. And the smallest microwave. So anyways, if this is a centimeter all the way across, that's a 5-week-old human fetus right there. 5-week-old human fetus. About a centimeter across. There's somebody's thumbprint next to the fetus. These are the nanocoils, all the things we saw in the page above. Here's a fairy fly compared to a human fetus. And such. Egg and sperm. Here's an egg and sperm. I should put it next to the human fetus. And then the human fetus 5 weeks later. Grows like 1,000 times. Okay, so here's the pulmonary alveoli next to your common mosquito. The fairy fly next to the common mosquito. Look how much smaller the fairy fly is with wings and everything next to your common mosquito. I'd like to try and see one, tiny. Largest brain cell next to a poppy seed. And look, somebody made the smallest chess pieces fit on top of a poppy seed. Look how small the smallest chess pieces are next to a mosquito. Or a mosquito next to a pulmonary alveoli. There's a large grain of sand and salt. So a large grain of sand is a little bit bigger than a salt. So here's 1 decimeter. Here's all stuff we're familiar with. There's a quarter, a nickel, a penny, and a dime. You know, a penny next to a grain of a rice grain. Oh yeah, sweat gland, of course. You see those little holes? Those are sweat glands. So anyways, here's a fetus, a 5-week-old fetus next to a penny. You could place it on top. Here's the pineal gland, right here. There's the size of the pineal gland next to your eye. And that little guy right there, next to the pineal gland, is the crystal that was growing on top of the pineal gland. You don't want that. Drink clean water. There's a fly robot next to somebody's finger, and those things can fly through people's veins to clean their arteries. That's an ant next to your finger, or a fly robot. Fly robot's about as big as an ant, or a small ant anyways. So, let's go down to the next one. 1 meter. Look, that's me. That's my hand. That's an Xbox. That's a large laptop. There's a 7-Up can. Basketball, tennis ball, golf ball, quarter, nickel, penny, dime. That's how big they are next to each other. And there's a fetus. So here's a fetus next to my hand. A 5-week-old fetus next to my hand. The pineal gland is about as big as a 5-week-old fetus. And you can see a grain of rice kind of there. So, 10 meters. Now the very highest... Ooh, we're pretty much out of time. So let's start up at 10 meters.